If the first known interstellar object passing through our solar system teaches us anything, it's that the interconnectedness of the universe reveals that extraterrestrial worlds are more similar to our own than we might have thought. The Pan-STARRS telescope in Hawaii discovered a faint blur on October 19th, 2017, while scanning the sky for potentially lethal asteroids. Its path was completely unprecedented. This asteroid from space was the first of its kind to be discovered. It's a cigar-shaped object careening across space on its end, an asteroid that traveled between stars for the first time. The name Oumuamua was chosen for the alien invader. Its unusual form contrasts sharply with the spherical nature of most objects in our own solar system. The terrific object sped through the sun at about 320,000 kilometers per hour. Its flat, extended appearance defied explanation, leading the creative human mind to consider that it could be alien technology. Elon Musk claims that its hidden characteristics contain a tantalizing hint regarding life and other star systems. What do we know about this enigmatic guest? Was the stranger among us a piece of a destroyed planet, or was it shaped and thrown toward our star by some mysterious forces? Why is it returning? Let's find out. Nothing else in our solar system looks like this. You've probably heard the saying, visit the galaxy before the galaxy visits you. Well, in 2017, scientists in Hawaii designated a tiny, reddish cigar-shaped object, Oumuamua, as a messenger from the galaxy. They found it in October, a mysterious cosmic envoy hurtling through the solar system at 40,000 kilometers per hour. A worldwide frenzy for telescope time to observe the object followed the discovery. Even SETI Institute astronomers joined in on the fun, launching a just-in-case search for extraterrestrial radio transmissions. Oumuamua resembles the known asteroids that we fear may one day crush the Earth and human civilization to smithereens in terms of hue and other ascribed characteristics. However, the asteroid's form is odd. It is incredibly extended, possibly 800 yards by 80 yards, at least 10 times longer than it is wide. Long ago, astronomers theorized that occasionally ice fragments ejected from the rocky disks forming distant planets would enter the solar system as interstellar trash. Such wanderers would appear as comets when they approached our sun, vaporizing and illuminating. But they have not been observed. Astronomers now understand why. There was no such cometary illumination on Oumuamua. It was only visible using a powerful telescope with a large field of view like Pan-STARRS, because it is so dim and black. Every 7.3 hours, Oumuamua dramatically brightens and dims, suggesting that it is spinning around its short axis. The small asteroid could only withstand that without exploding if it were constructed of harder, more durable material than the soiled snow that most comets are comprised of. Oumuamua is dark red, similar to several moons in the outer solar system whose ice organic molecules have been damaged by radiation from space, according to spectral data. Dr. Meach suggested that iron might also contribute to that color. Oumuamua's origin of shape is currently unknown. Maybe a supernova explosion sent it hurtling away from its star of origin, Dr. Meach suggested, or perhaps a pair of things collided and stuck together to produce it. Where did it originate? Astronomers were originally thrilled when the orbit appeared to point to Vega, the brightest star in Lyra, which is known to contain a debris disk. Astronomers calculated that the item would have traveled from there to here in around 600,000 years. However, the likelihood that Vega was the true source has decreased as a result of significant trajectory modifications. Oumuamua is believed to have encountered a new star system, for the first time since it was moving relative to the Sun at a speed that was similar to other nearby stars. However, it is not impossible that Oumuamua has been circling the galaxy for billions of years. Looking up at a sky where the stars appear independent and sovereign, gleaming away in loneliness, you could assume that the adventures of this asteroid and its ilk present a totally different picture of the galaxy. The gold in the wedding bands was made in the collision of neutron stars, just as the oxygen and iron in our blood were created in a supernova explosion long ago and far away. We now understand that meteorites released by asteroid impacts on Mars frequently touch down on Earth. Otherwise, credible astronomers hypothesized that one of them may have brought life to Earth that originated on Mars long ago when it was warm and wet. But to find our connection to the cosmos, we can go even further out and back in time. Consider Oumuamua's potential travel time of hundreds of thousands of years. Even if it may seem like a long time, in cosmic terms, it is a blink. The Milky Way galaxy is 10 billion years old. Therefore, little Oumuamua may have traveled through 20,000 star systems during the span of our galaxy's lifetime up to this point. While this is a small portion of the galaxy's 200 billion stars, it is nevertheless a respectable amount of stamps on its cosmic passport. As a result of Oumuamua's trail of dust and debris, the galaxy's stars and planets became mixed up. The universe might perhaps be quite little after all. While it may no longer be in view, the solar system has not yet lost it. Elon Musk and other astronomers predict that Oumuamua will enter the Kuiper Belt in approximately 2024 and pass through its edge in late 2025. He estimates that it will pass by the Voyager's most remote point in 2038. Although our Oort cloud is expected to expand beyond 100,000 AU by 2196, it will once more be 1,000 AU from the Sun. Consequently, depending on how you define the edge of the solar system, you can determine when Oumuamua genuinely crosses it. However, since Oumuamua has been out of reach for astronomers, they are currently making the most of the information they were able to obtain over the course of just a few months in order to understand as much as they can about this weird intergalactic intruder. Oumuamua, which is about 2,600 feet long and around 260 feet wide, was initially thought to be an asteroid by onlookers. However, astronomers and scientists noticed that Oumuamua was not traveling as it should. Instead, it demonstrated a really significant non-gravitational acceleration, indicating that other forces in addition to gravity were controlling its motion. Meech claims that there were a number of things that could cause acceleration in that direction. At least 6 of those potential causes of acceleration were looked into by her team, but several were rejected along the way because they either required an object to be extremely strange to be plausible, for example, less dense than aerogel, or because the acceleration they generated didn't match what was observed. The scientists came to the conclusion that comet outgassing was the most likely explanation because it occurs frequently in comets. When a comet approaches the sun and becomes hotter, the surface ices sublimate, going straight from a solid to a gas, a process known as outgassing. As gas leaves, it gives the comet an extra push that deviates from gravitational factors, changing its speed and rotation. This extra push causes the comet to rotate and move in the other direction. The motion of Oumuamua was comparable to comets in terms of power, therefore it didn't feel strange. Meech claims that the lack of dust emerging from the thing was remarkable. The more strongly a comet is outgassing, the larger the grains of dust it can release. However, even if the comet was devoid of microscopic material, massive dust may have been coming off the surface and influencing its speed. This kept the comet notion alive. Furthermore, scientists were studying at visible wavelengths where big dust is harder to observe. Therefore, no dust was observed leaving Oumuamua. However, what about gas? We also failed to spot any gas-related evidence. Strangely, astronomers anticipated a fair bit of gas to be leaving in order to impact Oumuamua's velocity in the manner that was observed. Meech's team searched for CN gas, which according to her is bright and simple to identify. So that is the caveat here. It can be used as a stand-in for water, which is more difficult to monitor, because CN is usually dragged off the comets in our solar system when water comes out, she explains. Yet when it came to their limit of detection, there was no CN at all seen. Since comets in our solar system can contain large amounts of water, the upper limit was strong enough to indicate that the comet was also exceptional chemically. If so much water were to come off, it originates from a different solar system, so perhaps that's not as shocking, she says. What else makes Oumuamua peculiar? Over 30 hours of observations of Oumuamua in the infrared were made by astronomers using the Spitzer Space Telescope, or rather they tried, according to Meech. She looks at the thermal infrared, which picks up heat, and adds, they detected nothing. However, occasionally even non-detections might yield information. They deduced from this that it must be brighter than anticipated if it exhibits comet-like thermal characteristics. Astronomers can learn a lot about an object's form, size, and composition by measuring its reflectivity or how much light it reflects. We just always assumed the reflectivity was comet-like and very low, explains Meech. But they were getting more like 10% reflectivity, as opposed to the regular 4% reflectance, which is characteristic with comets. So once more, that doesn't quite fit a cometary body, if you suppose it has extremely different thermal properties on its surface than other comets. The only way they could get it to accord with a 4% reflectivity is if you make that assumption. So once more a little odd, she says. Additionally, no detectable carbon monoxide or carbon dioxide outgassing from Oumuamua was seen during the same infrared studies. This is significant because Meech's team had considered the potential that it was exhaling those two gases in substantially higher amounts than suggested by the Spitzer observational limitations. It's always a little tough to extrapolate too much from what you don't see. Yet again, it doesn't appear to be as cohesive as a regular comet. Since Oumuamua was created in a different solar system, it's possible that all these peculiarities are typical of objects that originated elsewhere. Oumuamua's trajectory was determined back to before it first entered the solar system by Corin Baylor Jones of the Max Planck Institute for Astronomy in Heidelberg, Germany, who then compared that path to the previous positions of 7 million stars tracked by the Gaia spacecraft. He had to rewind the orbits of the stars in the galaxy, in addition to Oumuamua's, in order to search for points where the two might conceivably overlap. Oumuamua's motion had 4 contenders that passed close enough to the rewound track to suggest that they could be the creature's residents using close enough. Elon Musk claims that when Baylor Jones was stargazing, Oumuamua's course had come within 1 to 2 Oort cloud radii, or 100,000 to 200,000 AU. However, even here, nothing was simple. The encounter velocities for these 4 possibilities were relatively high, ranging from around 6 to 16 miles per second, which is the sole drawback. Oumuamua is most likely a planetesimal or construction block that was expelled during the genesis of planets, and it's quite rare for planetesimals to experience ejection velocities this high simply from coming into contact with large planets. Only a few miles per second would have been our prediction. These are high then, although it's not impossible. It's quite unlikely. If Oumuamua originated in a binary star system, that scenario would be more feasible. However, none of the 4 contenders were known to be binary stars. As is only natural, the upcoming Gaia data releases could be useful in assisting astronomers in finding a more suitable candidate for Oumuamua's home by enabling them to further backdate the motions of neighboring stars. In a few years, it would be wonderful to go back and review this. The first and so far only extraterrestrial visitor that we have seen zipping through our solar system is still Oumuamua. Even though there is little data on it, experts from all over the world are nevertheless interested in what might be hidden there. It's undoubtedly a fascinating object due to its peculiar characteristics. Some have even asserted that it was built by true aliens. However, a draft article by a Harvard scientist and the chief of the Pentagon's UFO office has suggested the possibility that an extraterrestrial mothership is in the solar system and is sending out microscopic probes known as dandelion seeds to examine the planets there. Could a mothership from another planet be circling the solar system and launching teeny tiny probes to investigate planets? Both a Pentagon official and a Harvard scientist believe it is feasible. The two claimed in a draft study that it is conceivable an extraterrestrial spaceship may be in our galaxy's neighborhood, investigating the area using dandelion seeds, tiny spacecraft that can collect data and bring it back, much like how humans send out spacecraft to explore planets. The document was revealed by Sean M. Kirkpatrick, director of the Pentagon's All-Domain Anomaly Resolution Office, AARO, which was founded in July 2022 by the Department of Defense, DoD, to find and investigate objects of interest, and Avi Loeb, an astronomer at Harvard University. It was done in collaboration with the DoD, but is not an official Pentagon document. Loeb is well known for his studies on Oumuamua. Loeb even proposed that Oumuamua was an extraterrestrial spacecraft 6 months before Oumuamua's close approach to Earth. A small interstellar meteor measuring around 3 feet in diameter smashed into Earth. Though not connected to Oumuamua, IM-2 was a meteor that attracted Loeb's attention. By chance, Loeb came to think that an artificial interstellar object might potentially be a parent craft that releases many small probes during its close passage to Earth. An operational construct not too dissimilar from NASA missions. The tidal gravitational force of the Sun, or a movement capability, might separate these dandelion seeds from the parent craft. Loeb and Kirkpatrick examined unidentified anomalous phenomena, UAPs, the government's favored term for UFOs, constrained by accepted physics in the draft study, since they would probably be too small to reflect enough sunlight for survey telescopes to notice them. The scientists hypothesized that the dandelion seed probes may travel to Earth for study without being seen by astronomers, they wrote. The technology, dandelion seeds could slow down in the Earth's atmosphere to prevent burnup and then follow their goals wherever they land if they had a large surface-to-mass ratio of a parachute. Scientists speculate that aliens would probably wish to study rocky planets in the solar system with atmospheres. Venus, Earth, and Mars would all appear alluring from a distance, with Earth being of greatest interest after visitors discovered signs of liquid water there. There would be no need for the mothership to contain the advanced extraterrestrial civilization that built the probes. It's doubtful that it could even exchange messages with the probes. Long before Earth originated, a habitable planet with intelligent life may have been sending out probes. Loeb compared looking for to checking our mailbox for any packages that may have accumulated there over time, even if the senders are no longer alive. Loeb has come under fire from the scientific community ever since he first proposed that Oumuamua was an alien spacecraft. The hypothesis that Oumuamua was intentionally dispatched to Earth, according to some of them, was provocative and baseless. In 2021, a letter that appeared in the journal Astronomy and Astrophysics refuted the notion that interstellar travel would be logistically impractical, given the likely cosmological timescales required to traverse between stars. We conclude that it is unlikely that Oumuamua has been sent by an extraterrestrial civilization, and more likely that it is just an unusually shaped rock which has just so happened to wander into the solar system. Another analysis disproves the idea that an alien spaceship is responsible for Oumuamua's peculiar movements by explaining them as most likely the result of hydrogen off-gassing. On March 22, 2023, however, over the past year, the Pentagon has developed a fresh interest in researching unexplained flying objects over American airspace. More than 360 additional investigations into purported UAP encounters reported by U.S. military personnel have been started by the ARO since its establishment last summer. The explanation for about half of these has been balloons or balloon-like entities, while for the remaining half, there is not enough information to make a firm determination. In any case, researchers like Elon Musk are hoping that telescopic scans will be able to detect additional extraterrestrial objects so that they and other researchers can utilize them to further test their hypotheses. If exoplanets are any indication, this is not an impractical dream. Only 20 years ago, the first exoplanets were found. As of today, more than 4,500 of these celestial entities have been confirmed. In around 10 years, statistics on the kind of objects that traverse the solar system should be available, and we should be able to learn a lot about other solar and star systems. Thanks for watching another episode of Space Voyager. While you're still here, make sure to click the video on your screen for more mind-blowing videos about space